So today we'll be discussing the scaling of MOS circuits. So we'll be explaining what is scaling, what are the types of scaling, what are the benefits or the advantage of scaling, and uh, lastly what are the challenges that usually faced by the scaling process. However, we can see that despite these challenges, so MOS scaling is becoming a driving force behind all the growth of the integrated circuit or VLSI, and that's a key technology to improve the performance, efficiency of the microelectronic circuit. So coming to the point, what is scaling? Scaling basically defines the process of reduction, the feature size and line width. To be precise, is a process of reduction. It is the process of reducing the dimension of MOS transistor and other components on a chip while maintaining or mostly improving their performance. So scaling means reducing the dimension or other components on a chip. So this scaling allows the increased transistor density, their functionality, performance gains. In other terms, scaling leads to improved performance, more transistor on die. That is, so more number of transistors while you are fabricating on a same die, so overall cost is going to be reduced. So purpose of scaling is to minimize the feature size, number of gates to be increased on the one chip, power dissipation to be reduced, operational frequency to be maximized, and moreover the production cost to be improved. So these are in short why we go for scaling. So there are three types of scaling models that are used in this VLSI. One is called the constant field scaling, sometimes referred as full scaling. Secondly, constant voltage scaling, and thirdly, lateral scaling or gate shrink, what is known as a gate shrink. You can see here for combined voltage and dimension scaling, this approach reduces the voltage and device dimension, both lateral and vertical side, by the same factor. So maintaining the electric field. So this results in a reduction of the power supply voltage, which can lead to lower power consumption, faster operation. But it sometimes requires increasing the doping density to maintain the charge field relation. Now coming to the point, combined voltage and we have considered two scaling factors, namely alpha and beta. So 1 by beta is the scaling factor for supply voltage, as well as the gate oxide thickness 1 by beta. So beta is the scale factor. So 1 by beta, that is the scaling for the supply voltage VDD and the gate oxide. Whereas alpha, there is 1 by alpha is the scaling factor for all linear dimensions, namely the transistor length, width and other. So constant electric field model, constant field scaling, which is known as, so in this case voltage and device dimension both are scaled, okay, by a certain factor. So both alpha and beta, they are non-unitary values. Both alpha and beta are be the same. Whereas constant voltage scaling model, in that case we fix the beta is as 1, that is only we have the choice of alpha. Okay, so scaling factors for device parameter. So you need to understand that these different device parameters, they are going to be affected by the scaling process. So gate area, gate capacitance per unit area, overall total gate capacitance, charge in the channel, so the channel resistance, transistor delay, maximum operating frequency, transistor current, switching energy, power dissipation per gate, power dissipation per unit area, power speed product. Everything is going to be affected by the scaling process. So in terms of alpha and beta, how these different parameters are going to change or going to improve, that we will analyze one by one. So benefits of MOS scaling. Benefit of the MOS scaling, as you can see, that increased transistor density, that is one of the most benefit. So more and more number of transistors can be packed into a smaller area, so it leads to more complex and efficient circuitry. Second point is improved performance. That is, smaller devices generally operate at faster speeds and consume less power. Okay. Power consumption, when we go for supply voltage scaling and dimension, power dissipation can be reduced significantly. And finally, lower manufacturing cost. Transistor scale down can lead to more efficient chip manufacturing and lower cost per chip. However, MOS scaling also faces some challenges. Okay, one of the important challenges is short channel effect. When the transistor is becoming smaller,